Hello, today we are going to learn another subtopic of chemical bonding. 4.4 Intermolecular forces. Learning outcomes. A. Describe intermolecular forces. 1. Van der Waals forces, dipole-dipole interactions or permanent dipole, and London forces or dispersion forces. 2. Hydrogen bonding. Basically, intermolecular forces has two types, van der Waals forces and hydrogen bonding. Van der Waals forces is divided into two. 1. Dipole-dipole interactions and 2. London forces. Dipole-dipole interaction, also known as permanent dipole, while London forces, also known as dispersion forces. As we know, van der Waals forces has two types. First type is dipole-dipole interactions. Dipole-dipole interactions can be formed between polar molecules. The forces arise from the attraction between permanently positive end of a molecule and the permanently negative end of another molecule. The strength of dipole-dipole interactions depends on the dipole moment of the molecule, which in turn depends on the electronegativity difference of the bonded atoms. A more polar molecule will have stronger dipole-dipole interactions. For example, dipole-dipole interactions of HBr is stronger than HCl. Dipole-dipole interactions is effective when polar molecules are very close together. The following is example of dipole-dipole interactions of HCl molecules. How dipole-dipole interactions is formed between HCl molecules. Chlorine is more electronegative than hydrogen atom. Electron density at chlorine site is higher than hydrogen atom. Therefore, this site becomes partially negative. Other side will become partially positive. Dipole-dipole interaction is shown from partially negative side on one molecule and partially positive side in another molecule. Second type of van der Waals forces is London forces. London forces exist between nonpolar molecules. It occurs because electrons in atoms or molecules are in constant motion. Now, let me explain the formation of London forces between bromine molecule. Initially, electrons distribution in bromine molecule are symmetrical. At any instant time, one side becomes partially negative while other side becomes partially positive. At this moment, this molecule is called as instantaneous dipole. Instantaneous dipole will induce neighboring molecule. And now, neighboring molecule is known as induced dipole. Attractive forces between instantaneous dipole and induced dipole is known as London forces. Next, the electrons will keep moving and electron distribution is symmetrical again. The following is some information about dipole-dipole interactions and London forces. Hydrogen bonding is another type of intermolecular forces. What is hydrogen bonding? Hydrogen bonding is attractive forces between positively charged hydrogen atom of a molecule and negatively charged electronegative atom of another molecule. The electronegative atom are fluorine atom, oxygen atom, and nitrogen atom. The covalent bond of hydrogen-nitrogen, hydrogen-oxygen, and hydrogen-fluorines are very polar. Now, let's take a look at the formation of hydrogen bonding between ammonia molecules. When the partially positive hydrogen atom of one molecule is attracted to the partially negative lone pair or nitrogen atom of another molecule, that is how hydrogen bonding forms between ammonia molecules. How about water molecules? The hydrogen bonding between water molecules is shown between partially positive hydrogen atom of water molecules and partially negative lone pair on oxygen atom of another water molecules. Could you please identify the formation of hydrogen bonding between alcohol molecules? First, identify a polar bond between hydrogen-oxygen bond in one molecule. Second, look to neighboring molecule. Find a polar bond between hydrogen-oxygen bond as well. Third, remember definition of hydrogen bonding. We have discussed it earlier. Let's recap about hydrogen bonding. Hydrogen bonding is attractive forces between the positively charged hydrogen atom of a molecule and the negatively charged negative atom of another molecule. In alcohol molecules, the negative atom is referred to oxygen atom. From this meaning, we can identify the formation of hydrogen bonding. Dotted line can be shown between hydrogen atom in one molecule and oxygen atom in neighboring molecule. Next, label the forces formed between these two molecules as hydrogen bonding. Identify the formation of hydrogen bonding between carboxylic acid. Question to be asked. Could you please identify what is X between amine molecules? Yes, it is hydrogen bonding. Our discussion for this subtopic is done. I hope you are able to understand everything about intermolecular forces. Thank you.